Okay, so here we are going to review the zero product property and the inequality classwork. So we're having a quiz on this pretty soon, and this is the quiz review. So if you can get everything that's on this quiz review, you should be just fine when it comes to taking the quiz. So if you have any questions, maybe you can, on any particular problem, you can just kind of fast forward and skim through the video to see if you can find the time when I go over it, or you can just watch the whole video if you're lost on like everything. But let's get started with solving the equations. So remember how this works, okay? When you're solving these equations, the point is it's using the zero product property, which means if you have a number times another number and the answer is 0, right? Some number A times some number B and the answer ends up being 0. The only way that this is possible is if either A or B or both is 0, because 0 times anything would result in 0. So we're using that property here because we have something times something else, and the answer is 0. So essentially, either x minus 7 is 0 or x plus 4 is 0. So our job is to find out what the value of x's are that could make those groups 0. And we need to find the solution to each parentheses, each group here, because this one could be 0, but the x minus 7 could also be 0. So we need to make sure we find all the possibilities. So the question is, well, what makes x plus 4 equal 0? And to solve this, we can just take x plus 4, take that group, set it equal to 0, and then solve that equation. So we can subtract 4 on both sides. We would have x equal to -4. So there you go. There's one of the solutions. You can also look at the other side, do the exact same thing. What makes x minus 7 equals 0? Well, just solve that equation and you'll know. Add 7 to both sides, you get x equal to 7. Let me kind of zoom in a little bit. Let's just focus on this. All right, so the two possibilities are -4 and 7. Let's look at B. So B is obviously very similar. So it's pretty much the same thing. You have x minus 5 times x minus 14. So our goal is to figure out what makes each part 0. So let's start with x minus 5. What makes x minus 5 equal 0? Well, if you add 5 to both sides and we solve this, we get x equals +5. And same thing with the -14. If we have x minus 14 equal to 0, we take that, set it equal to 0, and we solve it. We would add 14 to both sides, and we would have x equal to +14, because 0 plus 14 would be 14. And we have those two solutions. Now for C, we have fractions going to be the result of this. But let's see how those come about. So the process is not any different, though. You want to figure out what makes that equal to 0, then you would take it and set it equal to 0. And we'll do the same thing with the 5x plus 8. We'll take 5x plus 8, set it equal to 0. Now, again, you're just solving these equations. What makes 2x plus 3 equal 0? Well, let's figure it out. Let's add 3 to both sides. Gives us 2x equals 3. And then because it's 2 times x, we will divide by 2. And we have our solution. X is equal to 3/2. 3 over 2, 3/2. So that's the first one. Now let's look at the 5x plus 8. What makes 5x plus 8 equal 0? Well, we begin by subtracting 8. We have 5x equal to -8. And then same thing as before with the 2. In this case, the 5, we're going to divide by 5. Gets the x by itself, and we see that it's equal to -8/5, or -8 over 5. And you can totally leave it as a fraction. There's no problem in that. So those are the answers for C. Now, if you look at D, we have a fraction, but it's not really that big a deal, if you ask me, because it doesn't work any differently than the problems we've done already. So if you take x minus 1/2, set it equal to 0, and then take x plus 21, set it equal to 0. And the same thing occurs as the last problem. So if you want to solve for x, you would just add 1/2 to both sides, and you have your answer. It'll be x equal to 1/2, because 0 plus 1/2 is 1/2. So x equals 1/2, and then with the 21, we would just subtract 21. We would have x equals -21. And we're good to go. So the rest of these follow those same properties. You take each of them, set it equal to 0, and solve them. There's nothing new here except for G. I'll look at G, but E and F you should be able to do if you follow the same steps that we were just doing previously. G is a little different. We have 5x, and because there's an x here, it's important. If there wasn't an x there and it was just 5, the 5 would be pretty useless. But the x is here, and we need to account for that. So it's still the same thing that all the other problems were. You have two groups, and both the groups equal 0, so you take both groups and set it equal to 0. So even though this doesn't have parentheses, it's fine. It's still considered a group or a piece. You have 5x. You need to know what makes it 0. So you take that group, you set it equal to 0. And you would also do the same with 2x minus 5. Take it and set it equal to 0. So just like on the previous problems, you set each part equal to 0. Well, you're setting each part equal to 0 here. You have 5x is one part and 2x minus 5 is the other. You set them equal to 0 and you solve. So for this one, we would divide by 5. And that's not really going to do a whole lot because 0 divided by 5 is still 0. But that is a solution that does count. We want to make sure that we've mentioned it. It is part of the answer. If you don't have that answer, then you're not going to be completely right. Now for the second one, we would add 5 to both sides to start. Then you'd have 2x equals 5 and then divide by 2 to get x equal 5/2. So if you hear a lawnmower, by the way, I apologize. They are mowing the yard outside. So moving on, consider the equations. 4 times x minus 6 and x plus 3 equals 0, and 2x minus 12 and 4x plus 12 equals 0. Do they have the same solutions? Justify your answer. So I'm just going to go solve both of these, and we'll see if they have the same answer. And because I show my work, showing my work will be the reason why it's justified. I can't just say, do they have the same solutions? Yes, they have the same solutions, and then not show my work and prove it. So I need to make sure that I prove it. So let's see. And I don't even know if it's yes. I haven't worked it out yet. So let's find out. Now the first one, we have 4x minus 6 and x plus 3. Now, because the 4 doesn't have an x on it, it's just a plain 4, it's essentially useless. Because remember, our goal is to figure out what makes these parts 0. Because if you had 4 times 0 times 0, then obviously the 4 is irrelevant. Because if you multiply it by 0, you'd still get 0 as the answer. So 4 can't be 0. That's why it's useless. But this can be 0. We need to figure out why or how. And that group could be 0. We need to figure out how. So just like before, take each part, set it equal to 0, and solve. So when you solve that one, you would have x equal to positive 6. When you solve this one, you would have x equals to negative 3. So now we got to see if these are the same solutions as the other equation. So the other equation has 2x minus 12. We'll go ahead and set it equal to 0. And 4x plus 12. Set that equal to 0. And we'll solve and we'll see if they're the same. So if we add 12 here, we'll have 2x equals 12. And then dividing by 2, we have x equals 6. So that one does match this one, so that's a good start. Now let's see if the other one matches x equal to negative 3. So when we solve it, we have negative 12, subtracting 12. 4x equals negative 12. Then dividing by 4. So we end up with x equals negative 3. So these do in fact match. So my answer is yes, they match, and this is the proof. Justifying my answer is literally all the work that you see here. I've justified my answer. I don't have to explain it. I mean, I can say that both equations, I can say yes, because both have x equals 6 and x equals negative 3 as solutions. So you're going to do the same thing for this problem here with 4x and x minus 5 equal to 0 and 2x minus 2 and 2x minus 10 equal to 0. So just to get you started, because that x is there, that x is actually important. We can't just throw away this part. We have to consider it like we considered the 5x up here. Because it has an x, it's more important. So we still have to take that group and set it up equal to 0 and solve. Just like x minus 5, set it up equal to 0 and solve. So find the solutions here. What does x equal? and then see if those solutions match the solutions you get from the other equation, from the 2x minus 2 and the 2x minus 2, if they minus 10. If they are the same, then you would say yes. If they're not, say no. But make sure you show all your work if you want to receive credit. It's just the same as this problem that I've done previous to it. So now moving on to inequalities. Write an inequality for each statement. So statement number 1, or statement A, I make at least $550 per month. So how much money am I making? I'm making $550 or more, right? Because if I make at least $550, then I'm making $550 or more, or higher than that. So to write this as an inequality, I'm going to use X as myself. I am earning more than or equal to $550. So the amount of money that I'm making, the amount of money that I make is either 550 or higher than 550. So that's where my X is coming from. The amount of money I make is bigger than or equal to $550. Now, look at B. The temperature is over 95 degrees. So X is our temperature, and it is over 95. So the temperature is more than 95 degrees. It's not equal to, because it doesn't say anything about being equal to 95. It just says it's over. It's above 95. So if it's above 95, then it is greater than 95. I must walk no less than 10,000 steps per day. So the steps that I walk, if it's not less than 10,000, then it is more than or equal to 10,000. I need to make at least an 85 on the test. So my score on the test has to be more than or equal to 85. My score has to be higher than 85 or 85. So it's bigger than or equal to 85. I cannot buy more than 15 bananas. So the bananas that I cannot buy more than 15. So I must buy less than 15. Now, can I buy 15? Yes. So it's less than or equal to 15. I just can't buy more than 15. I have to buy fewer than 15, so less than or equal to 15. Okay, I'll leave the rest there for you. I think you sort of get a general understanding. If you can understand those, hopefully you can get those. If you have questions and you want to check your work, you want to ask me about these in class, ask me about them in class, okay? Write the inequality and solve. So Sarah is saving money to buy a new car. She has $5,600 already and saves $350 each week. She wants to buy a car that costs at least $9,000. How many weeks does she need to save until she has enough money? So she has $5,600 currently, right? So what we're going to do is we're going to have how much money she has or is making on one side and then her goal on the other. So she's at $5,600 and she's going to add to that $350 each week. So $350 W. I'm making this times W and putting W instead of X, W for week, because it's $350 every week. So the 5,600 is not going to change over time. It's going to stay 5,600, but we are going to add this amount over time, which is why we have 350 times W. 350 every week that goes past. Now, it's an inequality. It's not an equal sign. She wants a car that costs at least $9,000. So she wants to have more than or equal to $9,000. If I make this less than or equal to, then she'll never be able to buy the car except unless it costs exactly $9,000, because she wants the car to be at least $9,000. So the value of her car, the amount of money she has to save, needs to be more than $9,000 or equal to $9,000 to buy this car. So now you just solve this. So the first thing I would do is subtract the 5,600. I'd have 350W less than or equal to 3,400. Now, this is very important what we're getting to here. If I divide by 350, and I take my calculator and I divide by 350, W is going to be greater than or equal to, let me get my calculator real quick. 3,400 divided by 350 is 9.714. W is greater than or equal to 9.714. But here's the thing. I'm not going to talk about 9.714 weeks, right? I'm talking about, she gets this money every week. So the question really is, if she waited 9 weeks, is that enough time for her to save up money? Will she have enough money if she saves up for 9 weeks? The answer is no, because it needs to be a little more than 9, right? So 9 weeks is not enough time, right? Is 10 weeks enough time? Well, since it has to be more than 9.5-ish weeks, then 10 weeks is enough time. So instead of writing it like this, I'm going to say that she needs to save up for at least 10 weeks. I'm kind of rounding it because I'm thinking about it from a, real life standpoint. Looking at this from, the real world, I'm not getting paid on the 9.714 week, right? I'm getting paid on the 9th week and I'm getting paid on the 10th week. On the 9th week, I will not have enough money saved because it has to be more than that. It has to clearly be more than 9. But on the 10th week, I will have the money saved. So the 10th week is the week that I can buy the car because I'll have at least $9,000, or I could save up more money after that. But 10 weeks is when I can start to look at cars to buy if I want to buy a car that costs at least $9,000. Let's look at B. Jerome wants to go go-karting. It costs $35 to go go-karting for 10 laps. Each additional lap costs 75 cents. If Jerome has $50 to go go-karting, how many laps can he race? So he has $35 to go go-karting, and then he's going to pay, in addition to the $35, he's going to pay 75 cents per lap. That's over 10 laps, of course, to go. Now, he has $50, so he cannot spend more. So he can spend less than or equal to $50, but he cannot spend more than $50 because he doesn't have more than $50. So the amount of money he spends has to be less than or equal to 50. So now we're going to solve this. We subtract 35. We have 0.75x is less than or equal to 15, and then divide by 0.75. We have x is less than or equal to, let me do the math, 15 divided by 0.75, 20. Is that right? Yeah, 20. So that's an even number. That's perfect. So Jerome can go for 20 laps if he wants to spend all $50, or 20 additional laps. I should say he's already getting the 10 laps for the 35. This amount of money, this is 20 extra laps. So he's going 10 laps and he can go an additional 20, which means the maximum he can go is 30 laps around the go-kart track. Because remember that he had 10 laps to start with, but each additional lap is 75 cents. So he can pay for 20 additional laps, therefore 10 plus 20, making it 30 total laps. So how many laps? He can race additional laps. He can race at least or no more than 20 additional laps. So in total, he will race somewhere less than 30 total laps. But I won't let that confuse you. I'll let you leave this as an answer and then say that he can have at most 30 laps. Now, Philip pays $10 to enter an arcade. Each arcade game costs 25 cents to play. If Philip has $20, how many games can he play? So Philip, he's got $10 to go into the arcade to pay. He's paying $10 to go in the arcade, and then he's paying 25 cents per game that he wants in the arcade. So we'll put G here for per game. Now, he has $20 to spend. He cannot spend more than that because he doesn't have that much money. He can only spend less than or equal to that $20. He cannot spend more than $20 because he doesn't have that. So when you solve this, subtracting 10, we have 0.25g less than or equal to 10. divided by 0.25 divided by 0.25. We have the number of games he can play is less than or equal to 40. So he can play no more than 40 games. If he plays less than 40 games, then he didn't use up all his money, which is fine, but he can't go over 40 games because he doesn't have it. So he can play any number of games up to 40 games. All right, so now let's look at the inequalities. Now we're just writing the inequality for each graph. Now these are compound inequalities. So for the first one, this is an OR inequality. You can tell it's an OR inequality because of the directions it's going. It's going opposite directions. OR inequalities will always go opposite directions. So let's focus on this one, and then we'll focus on the one on the right. So on the one on the left, it's x is less than, because it's going this way, it's going to the numbers that are less than -2. It's not less than or equal to, because it's not a shaded circle. If that circle there was shaded, it would be less than or equal to, but since it's open, it's just less than. So it's x is less than -2, or the other side, we have x is greater than 5. Again, it's not greater than or equal to, it's just plain greater than, because it's an open circle here instead of a closed circle. So there's your inequality. X is less than -2, or x is greater than 5. Now, if you look at B, this is an AND inequality. You could tell it's an AND inequality because it's shaded in between. The two shades converge here in the middle. They're not going opposite ways like in A. So an AND inequality, remember, you kind of start by writing like this. It always has the x in the middle, the arrows going the same way. I shouldn't say arrows, I should say the inequality signs, right? And it starts from -2 and goes and ends at 5. Now, there's one little catch, is the fact that this is a closed circle, so it could equal -2, but it's an open circle on 5, so I'm just going to leave it as just regular sign for -5. So this is how you write an AND inequality. You write it with the x in the middle, and the smallest number on the left, the biggest number on the right, because what it says is -2 is smaller than x, because x is here, which is clearly bigger than -2. And x is less than or smaller than 5. So it's shaded this way because it's less than 5. It's more than 2, and it's less than 5. So it's shading right there in the middle. It's shading right there in between. C is another OR inequality. Again, you can tell it's OR because it's going opposite ways. So we have here x is less than or equal to -2. Or I should say, or x is greater than 5. Is that like the same one? No, it's a little different from the first one because that one has the shaded circle, so it's less than or equal to. And D is another AND inequality because it's shaded in between. So it always kind of starts like this. It starts at -2 and ends at 5, but it does include both of them because they're both shaded, so it's less than or equal to on both of these. -2 is less than or equal to x, which is less than or equal to 5. I'll let you guys finish those last 4. They're very similar to these. Just make sure you identify whether it's an OR inequality or an AND inequality at first, because that usually helps. When you know it's an OR inequality, you're going to be writing it like this. And when it's an AND inequality, you're going to be writing it like this. All right. That's going to be it, guys. I hope that helps for the study guide. I hope that helps you get ready for the test. If you still have questions, just send me a message on Remind. Let me know before class, whatever you got to do. Okay? I'll see you guys later.